Areas of similar figures, Lesson 11.5. When we look at area and comparing areas of similar figures, we're looking at side squared because we're taking a base times a height. So if I'm going to compare the two areas to two sides, and this one we know that AB and FG line up, I would have to take both those sides and square them to compare them to the area. So that's why we have this formula right here. The area of one over the area of another would be the square of the two sides that are corresponding. So if I look at the first example problem, I have DC and RS, and we know that those are sides that are corresponding that would have to be in the same proportion. So if I did those sides squared, 6 squared over 9 squared, it would give me the area of the smaller one, which is 48, over the area of the one I want to find, which is a larger one. So when you set these up, you have to be careful. The side that's 6 inches long goes with the area that is 48. So they're both in the top. And then 9 and the area that we don't know would be both in the bottom of the equations. So now I would have 36 over 81 equals 48 over the unknown area. Cross multiply. 48 times 81. And then I would divide both sides by 36. So the missing area is 108 inches squared. In the next one, we're told that the area of triangle ABC is 98 inches squared, and the area of the smaller triangle, RTS, is 50 inches squared. We're told that they're similar, and we want to find the scale factor and the value of x. So if I did 14 squared over x squared, the two sides that correspond to each other, equals 98 over 50. I would then have 98 x squared equals 14 squared times 50. So 14 squared is 196 times 50. I have 98x squared equals 9800. So x squared would equal 100. Square root both sides, and I have x equals plus or minus 10. So I now know that x equals 10. And the scale factor would be 14 over 10, which reduces to 7 over 5. And this is the scale factor. That concludes our lesson 11.5.